Hello, everyone. Welcome to today's webinar. My name is Khalil Doheny, and I'm Director of Content Marketing at Digital Niche Agency. Today, we have the team from Atombeam. Team, how are you guys doing today?
Great. Good to see you.
Awesome. Really excited for today's webinar. We're going to have Charles always with his presentations, and they get better and better every webinar. So excited to show what he has here for you. And then we're going to have some Q&A. Charles, Josh, is there anything you guys wanted to add before we jump into things?
No, I just wanted to make sure everybody knows who Josh is, given I've done all these. Everybody knows me. But Josh, do you want to talk about what you do and so forth, not only for the company, but also outside of the four walls of Atombeam?
Josh Cooper, Chief Scientific Officer, Atombeam. Been with Atombeam more or less from the beginning. I'm also a professor of mathematics and computer science. My background is really in combinatorics and combinatorial algorithms. These days, that dovetails with machine learning. A lot of my recent work in the past few years has been in various topics related to machine learning.
Right. Thanks. Today, we're going to be talking about something I think is pretty important and also really interesting, which is our newly named main event product, which we're now calling Nerac. And I'll explain why it's no longer being called Compaction. Now, Nerac does still compact data, but it is only one of the features that it has. For a few reasons, including the need to trademark the name, we are now calling it Nerac. I don't want to hear any groans or I don't like it, or it's like, sorry, that's what it is. We're also going to talk about, and this is mainly what Josh is going to be just talking about, which is why Nerac is so important for the potential of AI, what it really means. But before we get going, we need to talk about this.
No money or other consideration is being solicited, and if sent in response, will not be accepted. No offer to buy the securities can be accepted, and no part of the purchase price can be received until the offering statement is filed, and only through an intermediary platform. An indication of interest involves no obligation or commitment of any kind. Reserving securities is simply an indication of interest.
I should emphasize that if you're interested in the offering, there's no real downside to reserving shares. All you're doing is saying, I'm interested. If you come out with an offering, you get a bonus shares if it turns out that the offering goes forward. There's no obligation, but there's also an extra bonus. So it's kind of like, why wouldn't you if you have an interest? Before we hit the key points here about AI, I'm going to quick what's going on with the company. The first thing is talking about this change of the name formerly known as Compaction. The new name being Nerac, and there's a few reasons why. First is Compaction is descriptive of what's happening, and therefore we can't use it according to the Patent and Trademark Office. We need to change the name regardless. Second thing is it sounds similar to Nercom or other product, and so now you can have a family of products and they sound similar. Another thing is the Ner part sounds AI related, which of course is appropriate. The most important thing about it is, besides the need to trademark it, is Nerac doesn't only make the data smaller. It isn't only compacting it. It's a transformation idea. It's the difference between just making the data smaller and looking at data entirely differently and eliminating a lot of the inefficiencies of ordinary data. How do you do that? And really, as far as we know, Nerac's the only thing you can do. And Josh is going to talk a little about that. Another really important thing, as of last Monday, we are now officially in release for Nerac, available on AWS now. We have multiple pretty big companies that are looking like we have a good shot here of getting them involved in it. It's a real product and people really want it. And we can now actually give it to them in a format that they want. Being on SaaS allows you to scale, allows us to maintain the code, allows a lot faster upgrading, onboarding, everything. It's the modern way to deliver software. Now, I'm going to talk a little about what's going on with DoD. So Nercom is the other product. That's the one that isn't released yet. It's in development and it's focused on images, audio, not the kinds of data that Nerac focuses on. Nercom The contract we have, it's $1.2 million contract with Air Force. They are testing it on synthetic aperture radar images that are generated by satellite as they pass aircraft, as they pass overhead of something. They're big images and they need ways of sending the data, the images faster than they do now. They're very excited about this and they're pushing us hard to get the development completed on this thing so they can actually use it. We're also looking at additional types of images that would be applicable here. Hyperspectral is probably the top one of those, but also LiDAR is another. We also have another $1.2 million contract with the Space Force to work on Nerac. They are pushing us really hard to go quick. They would like to move it into a phase 3 as soon as we can get there. And we're trying to get there as fast as we can. There's a lot of work on both of these things that are underway, resulting in us getting revenue. It's all good. All the work that's happening with both of those two products are equally applicable to anything we do in the commercial side. And some of you probably remember in December, we did a webinar with Admiral Becker, who is recently retired, who is joining our board. Admiral Becker, when he was in the Navy, was in charge of all the Navy's communications and intelligence systems. He was the commander of the Naval Information Warfare Systems Command, which is 11,000 people. He's a major leaguer. Going around at a conference with him a couple of weeks ago, it was admiral after admiral after admiral that we talked to, and it's very much a different conversation when a guy like him, who's very well known and respected, opens a conversation or they open it with him. We have a bunch of interest from a bunch of different commands. One thing we're planning to do is next month go down to the Navy facilities in the Charleston area and do demonstrations. The Air Force and the Space Force and other parts of the Navy want to send representatives to observe. So this is like a really big deal. And the last thing I wanted to mention here in terms of contracts and so forth is we just got another phase 1 yesterday. So that's 75,000. That's for NERCOM Plus. That's the working name. We don't know what we're going to call it yet. And Josh, do you want to mention a little about that? Because that's Josh's baby there.
The idea is to have a one-step process for compacting the data, for shrinking the number of bits being used for a given transmission, and at the same time, encrypting it in a provable way. So providing some guarantees about the security or privacy of the data, in addition to reducing the total footprint of the data, without having to do a multi-step process where you wrap Nerac data into encryption, or having to do it in 2 steps, or having to use specialized hardware to perform the encryption process. There's a number of downsides to trying to use encryption in various settings. One big one is that there really is not a lot out there in terms of encrypt data without increasing its size. Typically, small datagrams get inflated by adding encryption. Well, we found a way to steer around those problems and can in one step do compaction and encryption. There's some work yet to make it a product, but we have the funding, like Charles just said, and we're getting there.
Thanks. One of the things to mention here too is that 98% of IoT data, according to various things you read, has no security, has no encryption on it. And there's a good reason for that, for the reasons that Josh was mentioning. It makes it bigger, it takes extra computing power. It is very difficult to deal with IoT type stuff. But when you're at the same time, and this is a core part of what Josh is going to be talking about, at the same time reducing the size and adding the encryption, it's pretty much a magic bullet, especially when you add in the searchability, which we're going to talk about here. So this is a key slide for how the military looks at Nerac. They think of it in terms of this. You're communicating with ships at sea, with aircraft, with that and the other. How many lines of text, and you can call it lines of text, you can call it pages, you can call it datagrams, whatever. How many of something can you send in a given period of time? It's overwhelmingly dramatic, the difference. This particular slide, pulled from a deck we use with DoD, this tells a story for those guys right away. It's not any different when you talk about commercial applications, really. This, in terms of the steps go to market, this is the first thing that people think about and need somebody to address. Now, on the commercial side, as well as on the DoD side, it's reasonable to expect that we're going to be getting into contracts with multiple big companies. We already have, as I mentioned, all this interest from the DoD side, but on the commercial side, You're going to see stuff moving forward here. I would caution everyone, though, that big companies don't just say, oh, here's a new technology, let's load all our stuff on it. That's not how it works. They got to do pilots, they got to do testing, they got to do stuff. The big thing will be, can we get contracts with these guys? Those contracts will be based on, we're going to put this group of gateways, of sensors, of satellite terminals, or whatever, using Nerac. We have very specific discussions with multiple parties on just doing that. Then you start to say, okay, now we're talking a much bigger potential market through that particular customer. Not only that, if Ericsson and Viasat both say, hey, we're using this stuff and it works and we're referenceable, well, guess what? When we go to Caterpillar, when we go to Ford, or we go to whomever, it's a lot different story. So it's all very important to get to that point. I'm confident that we're getting there. So I want to talk a little about money. Everyone would want to know, what are you doing? How much money do you have? So we got 2.4 mil in the bank as of yesterday. We brought in $640,000 in revenue so far. And our core burn rate is about $300 a month. But you load on other expenses, especially if we're going out and raising money, and we got to advertise. We got to pay those DNA guys. We got to do all this other stuff. That costs money too, even if it isn't the core internal stuff that the company experiences on the offering. I just want to be really clear. I can't tell you squat about it, other than we have provided our proposed documents to the SEC. We're waiting to hear back. We should hear back this week. There's other things that have to be done. If they approve it, if we get back and everything's good to go, we think that probably mid-May is probably our best guess for the timing. At this point, it's not really driven by us, and it hasn't been for a month or so. It's really driven by the SEC and the other regulatory bodies. But other than that, I just can't talk about it. So if you ask questions, I'm just going to say I'm sorry. We have increased this company's size pretty dramatically now. We have some really senior, experienced guys. One of the things about operating a up is there are lots of pitfalls. There are lots of things that people try and didn't work, or don't work, or want to try, but an experienced hand knows that's not going to work. What we've intentionally done is go out and hired really experienced guys. There's a fair bit of gray hair here. It's with a reason. We're not saying, oh, well, you're only going to hire old farts and stuff. That's not the point. We want to hire in key positions, at least for now and for the reasonably near-term future. We want guys there that have already made the mistakes. They've already tried the thing that didn't work. And no, this is the thing that you need to do. And also to keep the focus, because a lot of people who haven't done this before go into it and say, well, why don't you chase this super duper opportunity? Whereas someone like Chuba, who's been around, done a lot of work with a lot of different companies, knows keep your eye on the ball. Even when I get excited to want to chase the rainbow, you're not chasing that rainbow. Turn around, come back here. And it's a good discipline. And it's a discipline of having people who have been there and done that. Younger folks, absolutely. People that haven't got that experience yet, those are coming. And there are here some now. But I got to tell you, we are really focused on, let's get this right first time. Partners, a similar set as we've had for a while. We have been waiting to release the SaaS to really go out and set up more partnerships. We don't have any issue with getting partners. We want them to be productive, and we want them to be real. We want them to be solid. This is the reason we're doing this thing, because it's not just a matter of sticking more logos up. It's a matter of saying this really brings value to Atombeam. Now, just really quickly, and sort of like where we see these products evolving. So right now, you've got this SDK. We've had that for a while. We're now moving into the SaaS. It'll be a continuous refining product. We have a hardware guy now whose dedicated purpose is hardware, which means boxes like a satellite terminal, like a gateway, or on chips like a microcontroller. Over time, evolving to actually being built into everything you could name. To get to that point where you really, really have super efficient, slap it on every logic board you can find, you got to be in something called ASICs, which are application-specific integrated circuit. And what it is a chip that only does one thing, which is, in this case, compacting data using Nerac. And then also IP cores, which is essentially the same thing, but they plug into a processing chip and is an add-on process to that chip. That's a $20 million gig. And so you don't do those overnight. You kind of start with FPGAs, which is a field programmable gated array, which sets you up to move to the IP core and ASIC. As the name implies, you can program them, and then you go, oh, mess that up. You can fix it. Unlike an ASIC, which is hardwired, done, you can't change it. So you got to have everything really squared away before you move to ASICs and IP cores. Net, there's a lot of evolution that's happening, but now we're really doing that evolution. It's getting into boxes right now. And that is frankly how most people will consume it. They'll get, say, a satellite terminal, connect to the SAS. And now these two things just talk to each other, and the guy doesn't know. He doesn't have to turn on a button. This is like a little reminder of Nerac. Probably some people are hearing this for the first time. Fundamentally, it's kind of machine learning, that application or algorithm that provides for the reduction of IoT, any datagram that has entropy, low enough entropy, which is basically anything that isn't a video or audio, makes them 75% smaller, and it does it in almost real time, like in microseconds. And because it can do it so fast, you can effectively send 4 times more data through a given pipe. Once the data has been encoded by Nerac, it's searchable and randomly accessible, and it adds in this security. Josh has already talked about this new version that we have coming, version that will just include encryption too. That's the key thing. Now, how does it do it? First, Nerac has a function that starts out by looking at a big data set, thousands of these little messages. And what it does is it looks not at the headers, the part that says here's where it goes, but it looks in the payloads, the actual information, looks between tons of these things, thousands, for patterns that it sees frequently. And it puts it into a code book. And the code book, all it is a bunch of these patterns. They might be 128 bits or 64 or 200 or something. And each pattern gets assigned a little code word. And the code word might be 3 bits, 10 bits, 5 bits, much smaller. When you're all done, specific to this kind of data, say it's generated by a particular gateway in an oil field, that particular data has got its own codebook. Now you take that codebook and you put it into the source and the destination. And what it does in runtime, it chops up that payload into whatever the lengths are of the patterns that are in the codebook. And then it swaps out the patterns in the payload for just the little tiny code words. And so all you've done is swap out the original data for the encoded data. And then in runtime, it's replacing all these patterns with the code words and then sending them back and forth from the two things. And it's sending them 4 times more data or 4 times faster, whichever. Bandwidth is 4 times. It's a very neat little thing that works incredibly well. But it goes way beyond the idea of reducing the size of the data. It's not just a fancy compression. It's a profoundly different way of thinking about how you manage data, how you handle data, to eliminate a lot of the extra stuff that doesn't need to be there. All the information that is in the payload before it's encoded is still there after it's encoded. That's the key point. Josh is going to take it from here and tell you why Nerac is a lot different than just fancy compression.
One of the key features that we've really focused on recently is this searchability. From a certain perspective, you might refer to it as random access. It really differentiates from pretty much all other data reduction technologies out there. The idea is that you use Nerac to compact your data, so you reduce the number of bits in your file, your message, etc. But then it's possible to read it in situ, in its encoded form. Not necessary to unpack the thing before reading it, or even it's possible to search it in its compacted form. Data is accessible, searchable, and readable without unpacking it. This means that if you've got a data lake full of log files or whatever kind of relatively low entropy data you've applied NERPAC to, it's not necessary to cart out the drive and unpack everything before attempting to find the thing you're looking for. It's possible to search it as is, even though it's encoded in this compacted form. And in fact, that's even true with NERPAC Plus that we talked about a little bit earlier, where it's encrypted. There's some minor technical caveats. The big picture is it's possible there also to read the data in its compacted form. So this can really change a whole lot of technologies. There are a lot of places throughout the IoT market where folks are simply not using any kind of data reduction technologies or even encryption technologies, because the encryption can add length to the data and compression can make it unreadable. It can also make it very brittle. One of the features we've talked about before is that if there's communication errors, there's noise on the line, then this essentially blows up any kind of classical compression. A file with a single bit flip is unreadable, usually. But that's not true for compacted data. In NERPAC, you compact the data if there's an error in the transmission or in the storage. It only impacts a few bytes in each direction. The data is still largely readable. Only a short retransmission, for example, is needed to repair the portion of the data that isn't read correctly. This can impact devices, whether it's your mobile phone, industrial IoT, satellite communications. This has the possibility to allow users to integrate data reduction into their data processing stacks without sacrificing readability and usability in place. We refer to data as a codebook as really a characterizing description of NERPAC. The idea is that any data that you get, unless it's already been encrypted or already been compressed, has inefficiencies. There's redundancies in the data that have to do with repeated patterns, predictability, essentially, that structure that you could, in theory, abbreviate. It turns out you can do it in practice too. This is really what we're taking advantage of. We're taking data and compacting it by stripping out all those redundancies and getting down to a stream that is very little in the way of exploitable room, minimal amount of transmission, minimal amount of storage space needed. Of course, there's a related technology, compression, that's been around forever, but you can compress your data and it's got all kinds of problems. So you can't compress very short bits because it will actually get longer. It ends up attaching headers, and basically the decompression instructions increase the length of the data. This means that it's useless, usually below about a kilobyte. Above that, even with huge amounts of data, it's unusable. You'd have to go unpack the whole thing to search it and to read it. This translates ultimately right into every computer, every server, every device got data flying around to be potentially 4 times more efficient, right? It varies by the data type and by the use case, but very typical to see something on the order of a 4 times factor improvement in all kinds of efficiency, whether it's power use or hardware costs or the speed of processing. Latency in particular is something that we're able to make a big dent in. The NERPAC encoded data is typically something like 3/4 smaller. It's only a quarter of the size of the original data, which means the left-hand side, if that's your system today, then you apply NERPAC to it on the right, you just freed up 3/4 of the system, whether it's bandwidth or hard drive space or whatnot. This doesn't make the sacrifice that the data is encoded in a way where it's unusable, but instead that portion of your bandwidth, your hard drive, et cetera, that's being used for the compacted data is now visible and useful in its present state. We've conferred security, privacy on the data. The data actually, even NERPAC Plus, without this additional steps of provable encryption, getting a deep obfuscation in the data that is going to frustrate all but the most determined attackers. And sort of famously, IoT data is mostly flying around out there without any kind of obscuring. There's a lot of vulnerability. I think in the coming years, we're going to see high-profile attacks on systems that use communications in the form of small messages because they just don't have the capability to encrypt it and to prevent attackers from getting access to it or even injecting their own data. With Atombeam NERPAC, You get that for free, essentially, from the technology. It's obfuscating in a way that's very hard for an attacker to do anything about. And with Nerac Plus, it's provably hard. We're working towards developing publications that certify that it has the required cryptographic properties, and also then transitioning to getting it integrated into some standards like NIST standards and other things that provide the validation so the users can be comfortable using it as a solution in their data stack. So of course, this increases available bandwidth by a factor of 4. It means that your data is more useful and more valuable. You don't have to drive the hard drives over on a truck and then pick through it bit by bit. Instead, it's visible in situ. Of course, this also can have the impact of reducing your hardware investments, because every wire, every processor, every hard drive comes with a cost, and especially in the AI and machine learning realms. In earlier days, we thought about all the different use cases, and there's lots of different scenarios where Atombeam Technologies can confer savings and open up markets to users. It's a new world in the past few years. We're seeing AI just changing absolutely everything. We're all familiar with LLMs, ChatGPT, etc. These extraordinary capabilities to inject intelligent decision-making into all kinds of different processes, not just chatbots, all kinds of things that really do impact bottom lines. The point is that actually Nerac is very well suited for its use in LLMs and more generally in all kinds of machine learning contexts. Of course, you can compact that as rather burdensome. Running a real bleeding edge application in machine learning, you need a huge amount of data, and this is really prohibitive. We can reduce that data, again, by something like 75% typically. And this means that data access and data storage and data use is faster. Training can be accelerated, and the burden of the costs associated with processors for training and deployment also massively impacted by applying Atombeam technology to the training data that is being used in order to develop these massive machine learning models. Of course, that also impacts the storage required by the models and the power to run the storage and the data access. More specifically, it's not just about the training data or even user queries, which are all, of course, compactable, and they're actually fairly low entropy data, so they're really well suited to Nerac. But in addition, a lot of the internal processing of modern machine learning, massive amounts of computation, parallel computation, largely happening on GPUs, TPUs, very expensive, specialized equipment in lots of cases. Huge amount of data is being passed back and forth during the training process and also during runtime when the models are deployed. Turns out that that data is very low entropy. There's lots of internal communication that's happening during the computations that are behind the scenes when models are asked to answer a question. That data is highly compactable. It is relatively low entropy, which means that you apply Nerac to it, then you can massively reduce the bandwidth demands and hardware requirements, storage included, of all kinds of different AI applications, of course, including LLMs. So this ability to reduce costs, but also to increase the utility and effectiveness of your hardware. You always have the option of buy less hardware because we can get away with less, or you use the same hardware and have a more competitive model to open yourself up to that many more users and new features that maybe today are not deployable on current hardware. With Atombeam Compaction, you can.
Thanks, Josh. Appreciate that. I'm imagining we have one or two people who would like us to answer some questions.
First question is, will the promotional film called Honey, I Compacted the Children be released on IMAX or regular Dolby Cinema?
Well, that decision's not been made yet, but talking to the casting agency today.
Awesome. What applications is PMAX and the other energy companies interested in?
That I can't go into any detail about. That is something the CRO is working on. He has a longstanding relationship with them. All I can tell you is that it's in the works and there's active conversation.
Has there been any feedback from customers using SaaS since its release on AWS?
I'm not sure. I don't think so. Guys are just starting to try it, right? It's really early days. It's been, a week since we released it. In the boarding call this morning, I didn't hear any specific feedback. We have our own internal guy who's kind of our simulated customer guy. He does a lot of the testing and, hey, this doesn't work, and hey, I found this bug or whatever. All that stuff is still happening, and being done and everything. I can't tell you that anything's gone wrong or anything hasn't gone wrong. I don't think there's any big issues. I don't have specific feedback, no.
The possibility of Atombeam is great, and that's why I'm an investor. Can you tell us rather the company's Atombeam will provide protection for American tech jobs?
That's a good question. I think it'd be impossible pretty much for any company to guarantee that. I would expect that Atombeam itself will be employing a fair number of tech guys, and we do now. All I could do is defend Atombeam empire, such as it is. Beyond that, everything gets more efficient over time, right? That's what we're really about more than anything else. To the extent that an American company is pushing forward on that front and has proprietary patented technology, we're up to 42 patents now. We've got some pretty formidable legs up on the rest of the world just with this technology that we have.
And then what's the update on the Viasat go-to-market?
I'm not sure what I'm allowed to say, but I will tell you there are meetings on a more than weekly basis. They are preparing documents.
Are there going to be manufacturing factories stateside for some of these mechanisms for Nerac?
I would think so. Josh, do you want to comment?
Of course, we're not a hardware company, at least today. Some of those technologies, FPGA, ASICs, et cetera, that Charles was talking about earlier are things that will need manufacturing when they reach product stage. I could see that becoming a manufacturing application.
Josh, do you think that the Nerac data and efficient tech will have an effect on the average American consumer?
Yeah, like I said, it's a technology where there's no ceiling. Every device basically needs some better use of resources, right? Everyone can benefit from the consumer all the way to the largest companies from being able to make better use of their hardware, send more data over the same lines, reduce their costs, et cetera. I could easily see, for example, AI being facilitated by Nerac being enabled to handle much more impressive computations on mobile devices. This would allow a developer to push out fancier features, more features, better processing to a consumer, despite them not upgrading the hardware.
And then with the amount of data being created, will you ever run out of code books?
No, the answer is no. Just to put things in perspective, there are situations where we've tried to see just how small you can make the code book. It's amazing how small it can get and really not sacrifice too much in compaction rate or other features. We've been able to get it down to 800 bytes in some cases. Really extraordinarily small.
8 bits. I've seen the 8-bit get down.
Well, that's the source block length, but even the entire code book, just 800 bytes. You think about even that number, you'd say, well, maybe are you going to run out of code books? The number of bits that expresses is 6,400. There's a lot of bit strings of 6,400 bits. That's way more than the number of particles in the universe. So I think we won't run out of space anytime soon.
Out of universe first. Right?
You've probably answered this question in the past, but how fragile is the data to bit noise or data dropouts? Or can an attacker make your data unreadable? This is my first participation in one of your webinars.
I think it's actually a key feature. Atombeam compacted data is really robust to noise. So typically, there's a bit flip or even a deletion in the data stream where you'll tend to see, as long as it's not, of course, ongoing corruption is all the data, but if there's a burst of errors, which is fairly typical in lots of applications, what happens is that then the next few source blocks, so this is on the order of 50 to 100 bits at a time, will be unusable, but then you immediately restored readability and usability afterwards. So very, very short stretches of data gets messed up if there's communication errors. Then the user has the option of, for example, using additional error correction to deal with those corruptions or asking for retransmissions of short amounts of data, things like that. I think it's actually a key feature that we're able to be really robust to noise.
A couple of key points. One is that's a big interest to DoD. They have people who purposefully are trying to interfere with transmissions. But the other thing to mention here is that we always talk about the little tiny datagrams that machines generate generally, but the bigger ones, if I'm sending a compressed gigabyte, compare that to sending a compacted gigabyte, then you sometimes cite the impact that we could potentially have on something like you've looked at Wikipedia, you download that and it's gigantic, everything, but one flip of 1 bit and you're toast.
And then any updates on use for data lakes? Is a company like Snowflake a potential customer?
Well, Snowflake has partnered with us. I think they're not quite sure what we are yet in terms of do we do what they do, except a lot easier and cheaper and faster and better. They do a whole lot of other stuff beyond sort of being able to find the data in a data lake, which they use a lot of AI and fancy stuff around. We could plug into potentially a lot of the algorithms they use to analyze it, how you pull it out, what it is, and all that stuff. All that stuff is stuff that they built into their algorithms that we would potentially be an add-on for. But Josh, you could say it a lot better.
I think you nailed it. We have talked to Snowflake, certainly interested in any situation where the user has, for example, massive amounts of log files that are kept in cold storage because they might need it for who knows what, auditing or QA purposes, et cetera. This is a huge problem when folks have these enormous data lakes because they're largely inaccessible. You have to literally roll the hard drive onto a truck and drive it over most of the time. But we're able to keep it in compacted state in a lot less space, have it still be usable and searchable and accessible to the user.
Then how do you monetize these products with corporations and the government?
Government, we can tell you right now, because we're monetizing as opposed to the plan to monetize, which is essentially they want you to go through a process with them to say, first, phase one, do you have something that is real and you could look at it, see whether or not it's developable or see whether or not it can be used to apply to some problem the DoD has. Phase two, you say, okay, I do have something real, they've decided. And yes, it is something that if it can be made to work in the context we want it to, then we'd like to investigate that further. That's when they give you the $1 million+ kinds of numbers. And then the third thing is if they say, yeah, this looks like it's going to work and I want to deploy it and so forth, then you get into the phase three or just contract phase, tens of millions, in which you are working actively with them. And it's a big scale thing to apply it to hundreds, thousands, whatever it is. On the commercial side, so we have a fairly simple plan for charging right now. It'll get more complicated. We have a retail price and a wholesale price, and we'll discount the wholesale price for the early adopters. This much per month per thing. That's it. It's pretty straightforward, intentionally as simple as we can make it at this stage. It'll get more complicated.
I know we only have a couple minutes here and there are some amount of questions. Let's try to just speed through these real quick. This is amazing. What does the rollout look like for a large company, assuming they have already gone through testing and want to roll out this to their entire company?
Here's an example. So there's a large satellite company that we've mentioned before that has a unit that does things for oil. Boatloads of data coming out of these oil fracking things, I think it is. It comes out of the things. It's sent over satellites. It's too much. They want to increase the amount of data dramatically, and they can't without our help. So we'll do a pilot project with them and a few hundred of these gadgets. And then that will be the pilot project that will, we hope, turn into a much bigger scale kind of a thing. All these big companies are the same. They want to see it work. A few hundred things. Their whole business doesn't collapse if you don't have what you say you have or there's some problem. Then they'll move on to bigger scale. Always that. So we won't see big scale stuff till late this year is my guess.
And that is our time. Charles, Josh, is there anything you guys both want to add before we hop off here today?
I'll say, come on and reserve because there's no obligation to do it. All you're going to get is a plus out of it. And it's good for us because we know that there's a lot of interest out there. And we have a freaking world-changing, huge thing. You saw those people know what the hell they're doing. We're now turning it into something real that people are going to pay us to use.
Awesome. We will be posting a replay of this webinar on the Start Education page. I know we couldn't get to all the questions. I know Charles just mentioned he would create an update with those questions, and we have them copied, and we'll get those answers for everyone.
You'll see those posted on the Start Engine update page. That's where they'll go. Awesome. All right. Thanks, everybody.
Thank you.
Bye.